Good morning, everyone. Myself Prachi and my teammates Heta, Meet, Shivang, and Neil will be presenting our project, which is Web Search Engine. Now, let us start with an introduction, followed by tools and documents, concepts used, functionalities, system design, demo, and we'll end our presentation with the conclusion. Now, Neil will take over from here.
Okay, so what is web search engine? A web search engine is a software system that is designed to search the information on the World Wide Web. The search results are often referred to as search engine result pages, that is SERPs. The information written by the web search engine can be web pages, images, videos, infographics, articles, research papers, and other types of files. The tools and libraries used for developing this search engine are: we have used Eclipse as IDE for developing search engine, JSON library for parsing HTML files to text, Lucene Snowball library for stemming process, that is for deriving the base word. Now Heta will start with the functionalities of the search engine.
Let's talk about the first functionality of the search engine, that is the web crawler. The two concepts used here are HTML to text converter and the regular expression. A crawler is the heart of the search engine. The process of the search engine starts with a crawler. The goal of such a crawler is to learn what every web page on the web is about so that the information can be retrieved when it's needed. They are called web crawlers because crawling is the technical term for automatically accessing a website and obtaining data via a software program. In simple words, a crawler is like a librarian. It looks for information on the web, or we can say on the internet, and catalogs or stores it so that the crawled information is retrievable and can be used. A web crawler bot is like someone who goes through all the books in a disorganized library and puts together a card catalog so that anyone who visits the library can quickly and easily find the information they need. To try to find all the relevant information on the internet has to offer, a web crawler bot will start with a certain set of known web pages and then follow hyperlinks from those pages to the other pages, follow hyperlinks from those other pages to the additional pages, and so on. We will see detailed information of web crawler in the upcoming slides. Now Shivang will continue with inverted index.
Now let us discuss about inverted index. We have used trie data structure to implement this concept. The trie contains all possible words in a collection of all web pages. Each leaf has a reference to a list of occurrences. The list of occurrences is stored outside the trie, which can be a hash map. The indexing helps to access the web pages faster and efficiently. In our project, before creating a trie, we have taken care of few hiccups which may lead to low efficiency while searching. Firstly, we have removed the stop words as they are most occurring and useless words in the document like I, the, we, and etc. Secondly, we have stemmed each word to its root form using the stemmer library. Whenever an user searches for some word like chocolate, the information about that word should be present in the trie. But the word present in the document or a text file is called chocolates or chocolatey instead of chocolate. To relate both the words, we have trimmed some part of each and every word so that we could get the root word, that is chocolate. This concept is widely used in retrieval systems such as search engine, which gives quicker response and better search experience to the user. Now Neil will take over from here.
Spell checking feature in our search engine is implemented using edit distance algorithm. In edit distance algorithm, there are two strings in which one string is transformed into another string by using any of the three operations, that are insertion of string character, deletion of string character, or substitution of string character. In our project, first of all, we are extracting all the unique words from directory of pages and creating a hash set of these unique words. Now, edit distance algorithm is applied on the search word by the user and all the words in the hash set, and the minimum distance is calculated between those. and the final output is the result of the minimum distance between the search word and the words in the hash set. The result can be only one word or a list of words. Now, Prachi will continue further.
Now, let us discuss how searching is done in our project. We have used HashMap to map the words corresponding to web page and for indexing purpose. The crucial part here is it stores the data in form of key value pair. Consequently, retrieving process becomes easy and efficient. HashMap is non-synchronized and cannot be shared between multiple threads without proper synchronization. Hashing helps in faster access of elements. The lookup time is pretty fast, which is big O of 1. Moreover, if we need to check if the stemmed word is present in the hash map, we can just use contain key method, which will return a boolean result. Additionally, it will help in avoiding the duplicate key insertions in the map. A search engine has considerable amount of data. Using a data structure like HashMap will improve the user's searching experience. Now, Meet will continue from here.
Let's talk about page ranking. So now, according to Prachi, if we have successfully retrieved all the links that are related to the search and stored it in the hash map, it's time to sort it or rank it according to the occurrences of the result appearing in the links. Here, we have used sorting method. A sorting algorithm is used to rearrange a given array or list element according to a comparison operator on the elements. The comparison operator is used to decide the new order of element in the respective data structure. In order to arrange the hash map into descending order, we need to first convert the hash map into stream, then sort it, and lastly collect and return a new linked hash map. This will give you the links with the most occurrences on the top. So here we have used stream.sorted method to sort the data, as it provides the property of reverse sorting, and also it has complexity of n log n, and it can run incredibly fast on large amount of data, which is very useful in real-time purpose. Now I would like Heta to explain the process of web crawler.
Let's understand the working of a crawler by a simple diagram. As you see in the figure, there is a crawler frontier. Now that will be the starting point. You need to give a base URL here. So here we have provided ca.news.yahoo.com to retrieve all the new information from the site. After, the crawler will retrieve all the hyperlinks that he finds on the web page. Now, as we are dealing with only news, we have here used regular expression to filter out the URLs that belong to only news links. As each link is retrieved, the page downloader comes into action. In simple words, we are using HTML to text converter to save the content of the page into the system for further use, which is the web repository in the diagram. And the cycle goes on until all the links from each and every page has been retrieved and stored. Now, I would like Shivang to explain the system diagram.
Search engine refers to a huge database of internet resources such as web pages, news groups, programs, images, etc. It helps to locate information on World Wide Web. User can search for any information by passing query in form of keywords or phrase. It then searches for relevant information in its data repository and returns to the user. You might be curious about how this actually works. Let us start with its architecture now. Search engine is divided into two parts. First one is crawling system, the second one is searching system. Initially, crawling system uses a web crawler that traverses the web to gather information. It will convert the HTML pages on World Wide Web to the .txt file using JSON library and will download them in the mentioned location. Now let us talk about searching system. Once crawler has downloaded the pages as shown in the diagram, it will be stored in a search engine repository, also known as warehouse of data. Moreover, all the data present in the repository is mapped using inverted index concept. To be precise, stemming is used to stamp each word and map it to each web page. This is used to make retrieval process more efficient and fast. Here we can use either trie or hashmap to store the indexing. Now, when the user searches for any data, the query will be passed to the query generator. Here, query generator comprises of following tasks. First one is ranking, the second one is indexing. In query generator, there are various filterings like removing of unnecessary words from the input query using stop word concept and searching for the stem word in the repository. If search is successful, it will map web page with its index, else it will create a new index. Now, PageRank algorithm will be running on this data and most ranked data will be displayed to the user. Ranking method uses query and indexes to create a ranked list of pages.
Now let's have a look at the demo of our web search engine. Now, to distribute the work equally, the very first and the most important part of the search engine, that is the web crawler, was implemented by Hita. Shivang designed and implemented the trie and the hash map structure for the inverted index, which was an important task for the efficiency of the search engine. Neil thought of the wonderful idea for the search suggestion using the edit distance and successfully implemented it too. Now, no search engine can be completed without the search process, and Prachi did the implementation of the same with a very low search time. Ranking the pages was an important part of the search engine to give user the accurate data, and that was performed by Meet very efficiently. And together as a team, we collaborated to integrate all the functions together into a working model and for the preparations of presentation too.
To conclude the presentation, all in all, using the concept we learned in the class, we have created a search engine that has most of the functionalities that a standard search engine must have, like search, word suggestion, and page ranking. We have designed a search engine which retrieves data from the internet as well as find information from system data store. So, these are the references that were helpful to us. Thank you, and we are always open for any questions.